Hello, my dear students. Once again, we are going to the subject chemistry. These are the some few questions in the chapter atomic structure. These are the questions asked in the some of the recent NEET and AIPMT exams. Here also, once again, I am stressing that you people should understand the subject and clearly you should know how to apply these principles at appropriate periods. So I read the questions and then I will explain how to do it. The de Broglie wavelength associated with a ball of mass 1 kg having kinetic energy 0.5 J is. So he wanted to know that the wavelength associated with the ball of the mass of the kg. Actually, it is dual nature. It is based on the question dual nature of the objects. So, according to that, all the bodies will be having particle nature as well as the wave nature. And de Broglie is the first man who has given dual nature to the bodies. So he has given a formula for the wavelength, which is known as de Broglie wavelength. Lambda is equal to h by p, where h is the Planck constant. That is, its value is equal to 6.6256 into 10 to the power minus 34. Here, p is momentum. Momentum has not been given. Instead, the kinetic energy has been given. From the kinetic energy, we can solve the momentum. So how? As it is explained, half m square is equal to 5j. You take this 2 to the other side of the equality, that is equal to mb square is equal to 0.5 into 2, that is equal to 1. Multiplying both sides by m, then it will give you m square v square is equal to 1 into m. Then we know that instead of this can be written as mv is equal to 1, mv whole square is equal to 1 into m. Then instead of mv we can put p, that is momentum. P square is equal to 1 into 1, p is equal to 1. So lambda is equal to in the above equation, lambda is equal to h by p. We know the value of h. P also we have find out. P is 1. Therefore, lambda is equal to 6.526 into 10 to the power minus 34 meter, which is very small. That's why in the macro particles, that is bigger size of the particles, we cannot sense the wavelength. Whereas in microparticles or fundamental particles, we can get the wavelength which is appreciably can be sensed. So, though macro particles is having wavelength, we cannot able to sense that wavelength. Here option is 1, and that I have explained how to solve this one. It's a very simple one. Only thing is you have to apply your principles appropriately. Next question, second, X-rays are emitted during. Here X-rays are somewhat more energetic rays. That means actually all rays are produced by the electronic transitions only. So if the transition takes place to the ground state from higher levels, we will get high energy rays, which is possible only K, which is very near to the nucleus. It will capture the electron from it, that is nucleus capture the electron from it. Usually X-rays are emitted by the higher metals when it is irradiated by some radiations. So the vacancy created in the K shell, that is lowest level, can be filled possibly by higher energy shells. So naturally the emitted rays will be the higher energy rays. That's why the correct action is capture. Now going to the question 3, which is the following radioisotope is used to as an anti-cancerous. So here actually all are radio isotopes only, and all radioactive races are having more energies, but cancer treatment we have to use a ray which is having sufficient energy, means that it is able to kill the cancer cells and it should not damage the surrounding healthy cells. That is most important. So that means we should have moderate radioisotopic rays, which is possible with CO60, and it has been used from so many years as radioisotopes without any safely and without dangerous to the surrounding healthy tissues. So C60 is the radioisotope which can give radioisotope rays or radioactive rays which are most suitable to the cancer treatment. Next comes to the orientation of the atomic orbitals in governed by. So actually, so the quantum numbers, in principal quantum number gives only the shell, primary shell or orbit in which the electron is present, and azimuthal quantum number what will give? It will give the orbital where it is there and what is its shape. If you comes to the magnetic number, which will give the orientation of the orbital, that is given by the azimuthal quantum number. And spin quantum number gives only the spin of the electron in a suborbital, either clockwise direction or anti-clockwise direction. So as per the given question, the suitable answer is magnetic quantum number. I think it is a very simple one. Only thing is you have to understand and should have clear meaning and knowledge of the quantum numbers. Next, fifth question. In the ground state, Cu plus the number of the shells occupied, subcells occupied, filled orbitals and unpaired electrons are respectively. So here Cu will be the, what will be the, you have to write the electronic configuration of the copper plus, means one electron is removed from the neutral copper atom to get the Cu plus. So the electronic configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. So from the outermost cell one electron is removed, so that we will get only Cu plus electron configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So here the number of shells, that is primary quantum number shells, primary cells are 3 only, first cell, second cell and third cell, and the number of the orbitals will be the number of the orbitals will be 6, 1s, 2s, 2p, 3s, 3p and 3d. There are only 6 orbitals, and a number of the filled orbitals will be the 1s, 2s, in 2p 3 filled orbitals. Totally, if you count the electronic configuration as shown in the figure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 are the filled orbitals. Unpaired electrons are 0, because in 4s one electron is there normal in a ground state electronic configuration, that has been removed to get Cu plus 1, so there will not be any unpaired electron in the Cu plus. So the option is 3, 6, 14, 0. So option is 3 is correct for this. So only here you have to you are able to write the electronic configuration, and to get Cu plus 1 electron has to be removed, then automatically you will get the answer perfectly. Next, going to the sixth. Assuming that you are traveling traveling at a speed of 90 kilometers per hour, in a small car with a mass of 1050 kg, if the uncertainty in the velocity of the car is 1%, then what will be, that means 9.9 kilometers per hour, what is the uncertainty in the position of the car? Here the mass of the car is given 1050 kg, velocity of the car 90 kilometers per hour, uncertainty is 1%, then we will get uncertainty calculated as is shown in this solution, 25 into 10 to the power of minus 2. Uncertainty, from using the uncertainty principle, h delta x delta p greater than or equal to h by 4 pi, where delta x is the uncertainty in position, delta p is the uncertainty momentum. We can calculate uncertainty momentum m into delta v, then we will get 1050 into 10 to the power minus 2 into 25. Then delta x can be calculated just substituting that. Then it will finally come to 2 into 10 to the power of minus 37 as shown in the solution. Here it is also very simple. Only thing is we have to write the uncertainty principle, and I have to calculate the uncertainty velocity. That is it should be converted into the meters per second. That it should be multiplied by 5 into 5 by 18. That's the only the thing. Remaining thing we can just substitute in the equation, we will get the answer. So because of this uncertainty, you might be knowing very well. If it is not there, in the sense, if you are not able to understand uncertainty principle, you can contact this website, this site for the general discussion in the subject. That means both for any particle we cannot get momentum and position accurately. If you get one thing is accurately, the uncertainty in the another thing is will become more and more, so that we cannot get both the things. That means perfectly we cannot identify the location of the particle. That is impossible. Likewise, the electron is also cannot be seen, because if you are able to capture its position, then the uncertainty in momentum will be more. That's why you cannot see it. Only thing is we have to get the information by its inference or experimental results only. Next, 7. If you go to the 7th question, smallest wavelength occurs for smallest wavelength in the sense higher energy levels. Smallest wavelength occurs in the Lyman series because it will be having more energy levels, because the electrons transmission occurs from higher level to the lowest level or the first shell, which gives the maximum energy. So if you get maximum energy means it should have smallest length. So that is possible only with Lyman rays, where the transition takes place to the ground, that is first length or lowest first energy level or the lowest energy level in an atom. So high energy levels will be possible only maximum energy levels possible only transition in the Lyman series, because it takes place from higher energy levels to the lowest level in the atom. Which of the following is wrong for the Bohr model? So, if you go to this Bohr's model, if you are able to understand the Bohr's postulates, then you can easily answer this one. Is to establish the stability of an atom? Yes, that is evident from the Bohr's hypothesis or Bohr postulates. It is inconsistently with the inconsistent with the Heisenberg uncertainty principle? Yes, because he doesn't know about the dual nature or position of the particle. He says that permanently it will be rotating in the stable stationary orbits. So it is inconsistent with the Heisenberg. It is not consistent with the Heisenberg uncertainty principle. It explains the concept of spectral lines by hydrogen-like species. Yes, it explains. That is also okay, correct. Electrons behave as a particle and wave. He has never told like that. He told that his electrons will behave as a particles and moves and revolves around the nucleus as a particles in the pattern of the solar system. So fourth is wrong pertaining to the Bohr's model. Ninth one, the threshold frequency of the metal is 5 into 10 to the power of 13 per second, upon which is 1 into 10 to the power of frequency light is focused. Then the maximum kinetic energy is emitted. That means here threshold frequency in the frequency below which if you focus the frequency on the metal, we will not get any electrons. That means this energy will be sufficient to bring the inner electrons to the surface. Then only electron will be emitted. The threshold frequency is the frequency minimum energy to bring it to the outermost surface of the metal. So to get out of this metal, you should have somewhat more energy than the threshold frequency. That from the concept of the photoelectric effect itself, maximum kinetic energy emitted is equal to h nu, where h nu is the energy of the incident light, and hu naught is the threshold frequency which is needed to bring the inner electron to the surface. Then from as per this calculation that has been done, we can easily calculate it. It is into 3 into 10 to the power of minus 20. Option is 9:2. Okay, that's next we will go to the 10th one. In Bohr orbit gives NH2 pi indicates. NH2 pi indicates what it indicates. If you study this Bohr's postulates, directly it will give you angular momentum only. He has told the same thing, where n is the number of the orbit and h is the Planck's constant. 2 pi is, as you know very well, about pi is pi only. Its value is 22/7 or 3.14. So in Bohr orbit, nh by 2 pi gives only angular momentum. It is evident from the Bohr's postulates. Next, going to the 11th question. The particle moving 3 times faster than the speed of the electron. If the ratio of the wavelength of the particle and electron is, then the particle is, what should be the particle? He has given here the ratio of the wavelength of the particles he has given. Then here we have to calculate the ratio of the wavelengths. So here the wavelength of the particle m, that is the particle which we have to find out lambda is equal to h by mb, that is de Broglie's equation we are using here. Then we can find out the wavelength, the velocities, ratio of velocities, which is equal to 3. Then we can substitute this into this one. That Vm by Ve we got is equal to 3. We can, as he has given the from this we can calculate the ratio of the Vm by Ve, which can be substituted. Then we will get m by mb, the ratio of m by mb we will get, from which we can calculate m, which is equal to the 18 into 51 ME, which is almost equal to the neutron or proton. Here proton has not been given, here neutron only given. Alpha particle is what is called a helium particle, and deuteron is hydrogen with 2 protons. Deuterium is 3 protons. So the clear option is neutron only. You can usually understand what are the in options, what the things has been given, what are they. If you know that, easily you can put the answer. Thank you very much. And if you got so from this pattern of the questions, we came to understand that we have to know clear understanding of the subject. If you are not, if any point is lag behind you without any explanation, it will lead to the disaster. That's why I advise you to understand the subject. Each and every point has to be cleared. For that, you have to contact our link, for which we can give you the clear explanation for bit to bit, and each point will be clearly explained. You can contact this link for clear explanation. Anyhow, I am given clear explanation to explain these questions also, but from the, if you chapter by chapter, if you go to get the clear explanation, then it is better for you to various types of question, how they can be asked and how the problems can be resolved. So first I will clear off these questions, explanations, then I will talk on the questions, how these questions can be asked in different ways. Even minimum a question can be asked 5 to 6 times, 6 types. How these things can be resolved? Only thing is, only it will be twisted, whether you understand the subject or not. So that's why I once again advising you, understand the subject, and I will give you the questions also, where say same question can be asked in how many ways. Few ways I will give and discuss it afterwards. First, let me finish this examination questions. Thank you.